Hello everyone, welcome back to the channel, and in today's video we'll see how to train a neural network for a binary classification task. Okay, so before jumping into the code, let's understand what the classification of binary means. Okay, so simply put, binary classification predicts is one of the two possible outcomes like spam or not spam for an email and disease or non-disease for a medical diagnosis problems, right? So here is our data set. It will be, wait a minute, it will be CSV. Yeah, so the data set that we have is around 1 lakh of rows, and the inputs features we have is age, income, and browsing results and browsing habits. And processing these three features, we have to predict that will the user would buy, like will the user will purchase something or not. Okay, and if it purchase, it gets at 1, and if it doesn't purchase, it gets a 0. Okay, so let's write the code now. So first we'll import our importer libraries. So I'm deleting this. Okay, so first we have NumPy, Panda, sequential API from TensorFlow Keras models, Dens from TensorFlow Keras layers, 10 test split for scikit-learn model selection, and standard scalar for scalar preprocessing, right? So I'm running this cell. Okay, and the next step is pre-processing the data, right? So let's begin. So here what we'll do, we'll simply load our CSV file first. So pd dot read CSV, and here I'll put my dataset dot CSV, right? And then simply data dot head 5 to check what the dataset we have. So we have age, income, browsing habits, and purchase. All right, now in X we'll have, let's say, age, and we had income, and we had browsing habits, and in Y we would have purchase, right? Then simply X dot head 5, and let's say for another one Y dot head. Okay, done. Now what we need to do, we need to split our dataset into training set and testing set, right? So X train comma X test, Y train comma Y test is equals to train test split. Then we have to pass our parameters, so X comma Y, and test size I'll be giving 0.2, mean 20% for my testing set and 80% for my training set, right? And for random state I'm keeping at 42, simple. It would be underscore random state. Okay, all done. But there we need to do one thing, we need to standard scalar our dataset. So for that I'll call this standard scalar, and then I'll just simply scale my X train and Y train. So X train would be scalar dot fit transform to pass the variable X train. Right? Okay. So now it's time for, okay, it would be normal X. It's also normal X. and then we have our X test here also, scalar dot transform X test, right? Let's run this cell now. Okay, so now comes the main part. We need to build our neural network. So here we'll build it. So I'll name it as model. I'll call the sequential API to sequential. Here I need to design my network, right? So I'll use dense function. In dense, I'll keep, for the input layer, I'll keep 16 neurons, and as activation function, I hope you know about activation function. So I'll be using ReLU for this, and as I said key, I'll be using this as my input layer. So I need to mention input shape. So in input shape, let's say for this case, I'm keeping it will be X-train in this case. So the shape of this is, and simply, okay, and I'll give one hidden layer just for the sake, dense. In hidden layer I'll keep 8 neuron, and as an activation function again I'll be using ReLU. That's the most best activation function that you can use. And for output layer we're using 1 neuron, and activation function for classification problem and mainly binary, we should always use sigmoid function. And why sigmoid function? Because sigmoid function always predict the value between 0 and 1, right? Because it gives you the value of the probability of between 0 and 1, so it helps. And we'll simply run this cell, and yeah, it will create me a neural network structure. Then we have compile the model. Here the process will be pretty simple. We need to simply use this compile keyword. Here I'll be using optimizer, and I'll be using Adam optimizer. Then for loss, as it is a binary classification, so I'll be using binary cross entropy, right? And for metrics, and these are some basic parameters that we should use, and accuracy. So let's check loss, binary, cost, entropy, all the spelling is correct. Matrix, optimizer. All right, so let's run this. Done. Now we need to train the model. How are you gonna train the model? For train, in history variable I'll keep my training model. So model dot fit, I'll simply pass the X train and Y train, right? And for validation data, I'll pass, okay, not here, here I'll pass X test and Y test, and epochs I'll be keeping 10, okay, and batch size I'll be keeping, let's say 32, and yeah, that's it. So let's run it, or what? Is it giving me any error? X train, Y train, I think it's pretty okay. Let's run this cell now. Yeah, so it will be giving me 10 epoch, so it will take some time. Okay, and by the way, yeah, if you want to like optimize your model more in the future, then you can play with this epochs and batch size variables, right? I mean, I have used 10 epochs, but in future you can use 50, 100, whatever as per your model. Okay, and then you can also play with this batch size. Then also you can use dropout layer, and dropout layers helps us so that our model doesn't get overfitted, right? So these are some basic things that you should be keep in your mind. But here I'm just showing you some basic structure of how to train a basic classification model using neural network. So yeah, and in future I'll be building more complex models, so there I'll be mentioning those processes. So yeah, it done. Okay, now our next part is evaluating the model. So for this, what we'll do, we'll simply calculate our loss, accuracy, model dot evaluate, model dot evaluate what I need to evaluate, x test and y test, right? And after doing that, I simply need to print this. So for print, I'll be using test accuracy into 100% to represent it in a percentage manner, right? Then simply I'll be using this. And yeah, so our model is performing at the rate of 90% accuracy. Now, as I said earlier, if you increase these epochs to 50 or 100, or if you in this layer, if you use like more hidden layers, more neurons per each and every layer, it will perform much better, right? So just some basic concepts, and for your experience and for your practice, I'll suggest you should use TensorFlow playground. I mean, let me show you what it is. This is TensorFlow playground, right? And if you are a beginner in this TensorFlow thing, then you should use all of this feature, and you should know that how those neurons works in the middle, right? So, and I'll show you in any of the next video in future. So yeah, that's it, and thanks for watching. And if you feel this video is helpful, so do like and subscribe.